So now what we want to do is we want to consider the angle, and we've decided what values we're going to use for the angles, ones that I judge can be described as popular: 0, 30, 45, 60 and 90 degrees. Now let's look at the hypotenuse. They've stated that it should all be at 2. We've got our angles that we've decided upon. The trick to aid in memorization more than anything else is to simply write root 0, root 1, root 2, root 3 and root 4. Of course, a lot of these can be simplified down, so you could argue, why would I do that? But the idea is it's much easier to recall if, for example, you are deciding that you want to remember these without a calculator, or you want to increase the probability that you will notice a mistake that you are making with your calculator. You can simply go up from root 0, root 1, root 2, root 3, root 4, and then simplify it down later. But in terms of remembering it, as long as you're aware that these are the angles for which you should recall them, and the pattern does continue. It continues though in the opposite direction. We can discuss that later. But for now, root 0, root 1, root 2, root 3, root 4, what can happen is then you can simplify that down to something very simple. You can say, well, instead, what I'm going to do is I'm going to say, well, root 0 divided by 2, I know it's just 0. That's that, and I don't have to consider that any further. The circumstance then of what is root 1. Root 1 is simply just, of course, is just going to be 1. If you want to take, for example, root 2, you keep that as it is. Root 3, we keep that as it is. And root 4 is 2 as well, so that's 2 divided by 2, and then that's 1 there. So what we have is sine theta, which describes the opposite divided by hypotenuse, or the relationship between the opposite and hypotenuse of a triangle. At 0 degrees is 0. At 30 degrees, it is half. That is, the hypotenuse is twice as big as the opposite. At 45 degrees, root 2 relative to 2, 60, root 3 relative to 2, 90, they are equal in size. The opposite and hypotenuse are equal in size. So let's look at that. So there's a simplification of that. Note that it's ratio. So when I say the opposite is 1 and the hypotenuse is 2, is the same as saying it could be 2.4, 2.55, 100, 200. It could be any of those values, really. Now, in these circumstances, let's take a look. Let's pay a little bit more attention to the root 2 over 2, just as a way of visualizing what's going on. The hypotenuse is of length 2, and the root 2, which is around 1.4, simplification, is this length here. So that means if you have a 45-degree triangle, the side, the length that goes straight across here, the hypotenuse was 2, and in every circumstance, the ratio between them is 1.4 to 2 for the opposite side. Another thing that we can consider is the 45 I can write as root 2 here, as I've done, as we've just discussed. And the 30 degrees, which is just a lower angle. It's a lower angle to the degree that, for example, I could draw it like that. And then I could say that that length there, for 30 degrees, as you saw, for 30 degrees, you have 1 over 2. So the hypotenuse is 2, which I haven't changed. There's the hypotenuse being 2 there, and hypotenuse being 2 there. But for 30 degrees, it is 1. Whereas for 45 degrees, it's about root 2, which is 1.4. So it being 1, I can then place it into my circle, because the hypotenuses are all the same. They will sketch out a circle, and this will be length 1 for a 30-degree triangle as depicted here. And it would become bigger by amount 0.4. So this one will become 1.4. I'll pick a better color, something slightly darker. This one will become 1.4 for that length for 45 degrees.